the bonding concepts, no? So, recorded yung class. Okay, so yan na. Okay, so, ito yung question, no? Why do atoms combine to form chemical bonds? No? Bakit daw kaya? No, anyone, any idea? You can use your mic, ha? Sana participative tayo. No? So, bakit yung atoms natin, they want to form chemical bonds? Okay, so the reason is they want to be stable. Okay, so our atoms, Khan Academy style tayo. So, our atoms, they form compounds, no? In order for them to be stable, no? Kailangan nila ma-achieve yung stability, no? Ayan yung keyword, no? Parang lahat naman gusto maging stable, no? Once, once you grow up, pagtapos na kayo sa college, ano gusto nyo? Maging stable yung life, no? Yung atoms, ganun din. They want to be stable, that's why they partner with other atoms, no? So, yan. Ang question dun is, bakit kailangan maging stable? So, let's look at our periodic table. So, tingin lang tayo sa periodic table. Okay, so these are our atoms, no? And we know that all of them want to be stable. No? Gusto nila maging stable. Paano? Ang nangyayari is that they pair up with other atoms, no, to form chemical compounds, ionic bonds, and covalent bonds, no. Okay, pero bakit? No? Kasi ganito, our atoms would like to imitate some certain elements here, no. May gusto silang gayahin na elements. Anong elements kaya yon? Any idea? Okay, ano yung element na gusto gayahin ng ating atoms? Yung mga noble gases, no? Okay. So what's with noble gases, no? Na gusto sila gayahin ng atoms, okay? Our notion kasi with noble gases is that they do not chemically react, no? Kasi ano na, stable na sila. When you say stable, their electron configuration is complete, no? The s and the p orbitals are fully filled. So yun yung idea, no? For a noble gas, para maging stable sila, kailangan kumpleto yung kanilang s and p orbitals, no? Except for helium kasi s orbital lang meron yan, di ba? Okay, so yun. So ito si neon, argon, krypton, xenon, radon, oganesson. So yan, may mga complete, ano yan, may mga complete orbitals, electrons sa orbitals, no? So once complete kasi ang electrons sa iyong atomic orbital, that means okay na siya, stable na siya, it will no longer react, no? Pero paano naman yung ibang atoms na hindi noble gas, no? So ano alam natin with the atoms na hindi noble gas? They have no complete valence electrons, no? I mean, hindi complete yung kanilang orbitals, no? Hindi enough yung electrons nila to achieve the stability of the noble gases, no? So yan. So anong gagawin nila? Okay. So ang ating atoms, no, may paraan sila to imitate the noble gas, no? Hindi naman sila pwede magbagong anyo. Kasi, for example, kayo, may ina-idolize kayong tao. Hindi naman necessarily na kayo magta-transform into that person. For example, kayo gusto nyo ng Korean. Gusto nyo yung Korean artist na si ganito. Wala akong kilala eh. So, yan. Kunwari gusto nyo siya. Gayahin. So, hindi necessary na ikaw pupunta ka ng Korea and then magpapalit ka ng citizenship, so on so forth. No, no. Instead, ano yung gagawin mo? Ikaw bilang K-popper, makikinig ka ng music nila, you will speak their language, no? And you will try kung ano yung ginagawa nila, no? Sumasayaw-sayaw ka, no? Yung mga dress mo, you act like how they act, no? So, ganun yung sa atoms natin, no? So, they want to... Teka lang. Okay. Andiyan na naman yung tindero na may music na maingay. Okay. So anyway, so yun. Ang idea is that our atoms, they want to imitate the noble gases again. The noble gases. No? Parang kayo lang yan. You want to imitate your Korean idols. No? So it doesn't necessarily mean na kayo ay magta-transform into a Korean person. No? Ganon din sa atom, hindi necessarily they will transform into a noble gas. Bawal yon. Instead, you will imitate what's with your idol. Ganon din sa atoms. No? They want to imitate kung ano meron yung noble gases. No? And ano ba yung madaling i-imitate? No? Yun ay ang electron configuration. Okay? So that's why we will now go sa electron configuration. No? Magre-review lang tayo na na-discuss sa laboratory nyo, yung electron configuration. Okay, so for example, let's take lithium. What is the electron configuration of lithium? Okay, so since its atomic number is 3, that means for a ground state lithium, meaning walang charge, 3 din yung electrons. No? Tatlong protons, that means tatlong electrons din. Okay, so what is the electron configuration? So according to Aufbau principle, you will start filling the orbitals of the lowest energy first, no? And that is the 1s2. Okay, so I place 2 electrons on my 1s orbital. So saan mapupunta yung isang extra? Sa next orbital, which is the 2s, 2s1. Okay, yung ating electron configuration, we can actually trace the noble gases here. Pwede mo makita kung nasan yung noble gas sa ating electron configuration. Paano yon, no? You just have to know the electron configuration of your noble gas. Pero ito yung tip ko. Ganito, technique. Alamin mo yung atomic number ng noble gas, then you start counting the number of electrons in your electron configuration. For example, helium, the atomic number of helium is 2. That means the second electron in your electronic configuration should correspond to helium. So, asan yung ikalawang electron dyan? From the beginning, ayan. So, ito, yung 1s2, andito mo makita yung helium configuration. No? So, ano meron dito sa 2s1? Okay, so hindi siya yung hindi siya yung noble gas configuration. No? So, ano yung idea ulit? Sa ating electronic configuration, you can actually trace where the noble gas is. No? So, ano yung technique na sinabi ko kanina? Just look at the atomic number of your electron configuration and you start counting the electrons starting from the left. So, helium is 2 in atomic number. So, that means the second electron in your electron configuration should correspond to helium. Ayan, yun yung 1s2. So actually, we can divide the electronic configuration into 2 parts. Now, pwede natin i-divide yung electronic configuration into 2 parts. The part wherein the noble gas is observed, yung noble gas configuration, I observe, and the one na nasa labas nun. Okay? So we call the noble gas configuration the inner electrons or the core electrons. No? So, yun yung mga nasa loob. No? Ito, ano yung alam natin with this electron configuration? They will not participate in chemical bondings kasi stable na yan. So, ano yung magpa-participate in chemical bondings? E di yung nasa labas. No? We call the outer electrons the valence electrons. No? Okay, so yan. So, that means our electron configuration consists of 2 parts. No? The first part is the noble gas configuration or the inner or the core electron. These electrons will never participate in chemical bonding. Ano yung magpa-participate in chemical bonding? Yun yung mga nasa labas, no? Yun yung mga valence electrons. Okay? So, yan. Kuha pa tayong isa pang example para mas makita natin. Ano pa kaya? Isip ako ng atom. Sodium. So, sodium, atomic number is 11. That means, if it is not charged, the electrons is also 11. Teka lang. So, yun. Napakaingay ng mga aso. Okay. So, the proton is 11. And if the sodium doesn't contain any charge, that means 11 din yung electrons niya. So, that means I am going to distribute the 11 electrons into distinct orbitals. No? I will start with the lowest energy level first. So, that's 1s2. So, I have 9 more in excess. 2s2 kasunod niyan. Ilan pa yung sumobra? 7, no? 2p, 6. Then yung next one, 3s1. Then anong gagawin natin? Once you're able to write your electron configuration, you have to trace where the noble gas is. Asan yung noble gas configuration dyan? Tingin lang tayo dito. Ano yung mga noble gases natin? Helium, atomic number is 2. Ang sumunod sa helium ay neon, atomic number is 10. So that means on the second electron, you will find the noble gas configuration for helium. For the 10th electron, you will find the noble gas configuration for neon. So ganun yung idea. Ano sabi ko? On the second electron, starting from the left, you will find helium. So that means itong 1s2, this corresponds to helium. Okay? So hanap pa tayo ng next noble gas. So sino yung susunod na noble gas? Yung ikasampung electron.
Neon po.
2, neon. So bilangin natin yung up to 10 electron. 2, 4, 10. So that means at my 2p6, I will have here my neon configuration. So anything outside it na hindi nagko-correspond to a noble gas, that will be my valence electrons. Okay? So my core electron would be this neon configuration. Hindi na yung helium, no? Sakop mo na hanggang helium, no? So that means I can rewrite this as neon 3s1, no? I can rewrite this as helium 2s1. Ito nasa bracket that corresponds to the electron configuration of the noble gas. Itong nasa labas, we call them the valence electrons. Sila yung mga outer electrons. And again, they are the electrons that participate in chemical bonding. Kuha pa tayong isang example bago tayo mag-proceed with the ionic bonding. Okay, so siguro fluorine. 1s2, 2s2, 2p, 5. Ano pa yung isa? Chlorine, Cl17. 17 ba si chlorine? 17 nga. So that's 1s2, 2s2, 2p, 6, 3s2, 3p, 5. Tama ba? 2, 4, 10, 12, 17. Okay. So, ganun din gagawin ko dito. Ano gagawin ko dito? I will trace the noble gas configuration. Hanapin ko yung noble gas dito. So sabi natin on the second electron, we will find helium. So andito si helium. On my 10th electron, I will find neon. Kaso, anong problema? Hanggang 9 electrons lang to. So that means hindi ako makakaabot hanggang neon. No? So I will write this as 1s2. Ay, mali. Helium pala. Helium 2s2, 2p5. Okay, so that is my condensed electron configuration. Then ito, dito tayo sa baba, no? So anong gagawin ko dito sa baba? I will trace where the noble gas is, no? Sabi ko, on the second electron, I will find helium. And on the 10th electron, I will find neon, no? So 2, 4, 10. So 2p6, no? Ano yung sumunod na noble gas? Tingin tayo. 18, which is argon. No? So yung 18th electron, that will correspond to argon. Tingin tayo. Si chlorine, 17 yon. So hindi tayo pasok kay argon. Okay. So we can rewrite this as neon 3s2, 3p5. Okay, so yeah. Wherein these are our valence electrons. Now, for fluorine, how many valence electrons do we have? Just count the exponents. 2 and 5, so that's 7 valence electrons. Ganon din dito. 2 and 5, 7 valence electrons. For lithium and sodium, 1 valence electrons each yan. 1 valence electrons. Okay, so ngayon, mag-isip tayo, no? How they will achieve the noble gas configuration. How will lithium, sodium achieve the noble gas configuration, how will fluorine and chlorine achieve the noble gas configuration? Okay, so ito yung idea. Si lithium, for it to be a noble gas configuration, dalawa yung kanyang pwedeng gawin. Una, pwede niya tanggalin yung 2s1 electron niya. Pwede niya ipamigay yung isang valence electron niya. As it do so, pag nawala yan, yung 2s1 electron, ang magiging noble gas, ang magiging electron configuration niya ay yung helium, which is the noble gas configuration. So that means for lithium to be stable, paglalabas na lang siya ng isang electron. Ano pa yung isang paraan niya? Another workaround is to get 7 more electrons. So, kukuha pa siya ng 7 pang electron. Bakit 7? Kasi ano yung next noble gas? Sa 10 electrons, di ba? 3 to. So, 10 minus 3, 7 electrons kailangan niya. Yan. So, ano yung idea? Pwede niya ipamigay itong valence electron na isa para ang noble gas configuration niya ay maging helium. Or, pwedeng gawin niya, tumanggap siya ng 7 electrons para ang maging noble gas configuration niya ay sa neon. Ang tanong, ano yung mas madali? E di yung step na onti lang yung kailangan mong gawin, no? I mean, yung onti lang kailangan mong effort, no? So, ano yung mas ma-effort? Yung tumanggap ka ng 7 electron. Isa-isa yun eh. 1, 2, 3, 7, di ba? Unlike, ipamigay mo yung isang electron mo, tapos na yung problema mo, no? So, what will happen here is ganito. Si lithium, instead of accepting 7 electrons, it would be easier for lithium to just give off its 1 valence electron. So, mas madaling ipamigay niya, ayan. No? So, isa yung ipapamigay niyang electron. Ganon din kay sodium, tingnan mo. Okay? So, ito. Sodium contains 1 valence electron. Mas madaling ipamigay niya yung isang valence electron na yan. So, ang kanyang configuration ay magiging neon na. Instead of accepting 7 more electrons in order for its electron configuration to be that of argon. Ma-effort yung tumanggap ng sobrang daming electron. So, mas magandang mamigay na lang sila. Okay? And that's the trend for the metals. No? The metals in your periodic table, they usually give off the electrons. No? Bakit? No? Kasi it would be easier for them to just give off the electron to be stable. No? Mas magandang mamigay na lang sila. So, ito yung mga galante nating friends. No? So, sila yung namimigay ng electrons. Okay, so yun yung technique. Metal, give off, electron. No? Punta naman tayo dito sa fluorine and chlorine. Tignan natin. So, similarly, fluorine and chlorine have the same dilemma. Kung gusto nila maging noble gas, dalawa options. Ipamigay nila yung 7 valence electrons nila para si fluorine, ang kanyang maging electron configuration ay helium at si chlorine ay maging electron configuration niya ay neon. So, pwede niya ipamigay yon. Ano pa yung isang option niya? Another option is to accept 1 more electron. Because again, ano yung next noble gas na ikasampu yung electron? Neon, di ba? So, kung tatanggap siya ng isa pang electron, that means magiging 10 na yung 10 na yung kanyang electrons overall. And the 10 electrons, no, that will correspond to a noble gas neon. Okay? Ganon din si chlorine. No? Ano yung next noble gas? Atomic number 18. Ito, 17. So, ilan na lang kailangan? Isa. No? So, ang pwede niyang gawin is, pwede tumanggap na lang din siya ng isa pang electron. No? So, pag tumanggap pa siya ng isang electron, argon na yung kanyang electron configuration, the 18th element. No? So, question, would it be easier for fluorine and chlorine to give up 7 electrons, or would it be better if it will accept the 1 electron na lang? The answer is, mas gugustuhin niya tumanggap ng isa na lang na electron. No? So, what will happen is ganito. For example, we have lithium and the fluorine. Susunod, wala na tayong electron configuration. gamit na lang tayo ng dots, no? Pero ito yung basis kasi ng dots, no? So, ayan. Kaya din i-discuss natin. Okay? So, that is the electron configuration or this one, no? 1s2, 2s2, 2p5. Or, okay. So, that is the electron configuration of the two atoms. Ano yung idea natin, no? For lithium, for metal, it would be easier to just give off this electron. So, ipapamigay niya ay ang electron papunta sa fluorine. So, that means, as lithium loses one of its electron, what will happen to its charge? It will be positively charged. No? Remember, every time you lose an electron, there is a corresponding positive charge. No? So, isang electron yung nawala, so positive one yung magiging charge niya. So, what will happen to its electron configuration? Magiging helium na lang. Wala na yung 3s1. So, napunta yung electron niya dun sa kabila, kay fluorine. Kunwari, siya yung partner niya. So, ipapamigay niya yung electron na yun kay fluorine. So, what will happen to fluorine? It will gain one electron. So, as it gains one electron, teka lang, its noble gas, its electron configuration will be 2s2, 2p, 5 plus 1, no? 5 plus 1 or 6, no? Magiging 6 na yung kanyang ano. And again, ano meaning kapag 10 yung electron? That will correspond to the noble gas neon, no? So, pag naging 10 na yung electron niya, ano mangyayari? Magiging noble gas configuration na siya. Magiging neon na siya. And consequently, since tumanggap siya ng isang electron, lithium will be negatively charged. No? Every time you accept one electron, may negative na charge sa iyo. If you accepted 2 electrons, negative 2 yung magiging charge sa iyo. Okay? So that's the idea. Our metals usually give off their extra electron, their valence electrons, to the non-metals. No? Non-metals yun yung nasa right side ng periodic table natin. No? Okay. So binibigay nila yon sa mga atoms na unti lang yung kailangan para maging noble gas. No? Okay. So yun yung dilemma nila. No? So kailan sila may mimigay ng electron, kailan tatanggap. No? Mamimigay sila ng electron kapag malayo sila sa noble gas. Meaning ng malayo is that it will require extra electrons para tumanggap, natatanggapin nila para maging noble gas. For lithium, that's 7 electrons. Effort yon. Pag pinamigay niya yung isa, mas madali. So yun. So yun yung tendency ng metals. Metals give off electrons, while non-metals, they accept electrons, no, in order for them to be noble gas. No? So yun yung idea. No? And what will happen? Since we now have two charged particles, we have lithium plus and fluorine minus. What do we know about opposite charges? They attract, diba? So yan, once they form charges, they will get attracted to form the lithium and the fluoride, no, combination. No? Ayan yung magiging ionic compound natin. No? So, kailan uli magiging ionic compound? Once you have opposite charges na. The positive will get attracted to the negative charge. No? And yun, magsasama sila because yun yung batas ng kalikasan. No? The law of electrostatics states that opposite charges attract and similar charges repel, di ba? So, yeah. So, once you have two charged particles, one is positive, one is negative, you have your ionic compound. No? You have your ions, no? Yung mga charged particles. No? So that is how ionic compounds are formed, no? So, ayun. So, yun lang. Ano uli yung, balikan natin yung nangyari. Why are we able to create ions? Because it would be easier for metals to give off electrons. Na ipapamigay nila yung electrons nila. For non-metals, it would be easier for them to accept electrons para maging noble gas sila. So as metals give off electron, they become positively charged. As nonmetals accept electrons, they will become negatively charged now. Sir, kailangan ba naka-electron configuration yan parate? Kailangan ba nakaganyan ko yan isusulat parate? Hindi, no? Kasi may isang tao, pangalan niya si Lewis, no? Around 1914s, no? 1914 na, alam ko na-awardan siya with a Nobel Prize about this, no? So, ang ginawa ni Lewis is that instead of writing this whole mess, ang dami we can represent the movement of the valence electrons daw using dots, no? Pwede mo na lang daw i-represent yung valence electrons as dots, no? And we call them the Lewis dot symbols, no? So how do we represent the Lewis dot symbols, no? Okay, so ganito. You just count the number of valence electrons. Sa lithium, ilan yung valence electron niya? Isa. So, one dot yan. One dot. Trotropahin, jojowain. Kayo bahala dyan. Yan yung one dot niya. Tapos, si fluorine, ilan yung valence electrons niya? 7. So, how are you going to place the 7 dots, no? Ganito lang, no? Iisa muna kada 4 direction. Top, down, left, right, no? So, 1, 2, 3, 4. Tapos, kapag sumobra ka pa sa, 4, you can start pairing. Sa 2, 3. So, yan. So, I have 7, no? Ayan. Single muna before you pair. Okay? So, yan. So, yan yung idea. So, these are the 7 valence electrons for fluorine. This is the 1 valence electron for lithium. Kailan mo daw malalaman kapag noble gas na yan? Ganito. Malalaman mo if that is a noble gas if number 1, for metals, wala na siyang tuldok sa labas. Number 2, for non-metals, 8 yung tuldok niya. 8 yung dots niya. Okay? So, yan. So, tignan natin. Paano natin i-represent itong transfer of electron from lithium to fluorine? Ganito lang daw sabi ni Lewis. Gagawin mo, your metal will give off its 1 dot papunta kay fluorine. Magko-comment siya ng 1 dot. No? Ilalagay niya yung 1 dot niya doon. Okay, so yan. So as it gives off its 1 dot, yung 1 valence electron niya, mawawala na yan dyan, no? Ayan, nawala na. So ano nangyari, no? Since lithium lost 1 electron, it will be a positively charged particle. Since fluorine gained 1 electron, it will be negatively charged particles. Kailan mo uli malalaman kapag noble gas configuration na? Kapag walang dot or 8 na yung dot, no? 0 dots, 8 dots. Doon mo malalaman kung noble gas configuration na yan. So, since dito wala na tayong dot and naging positively charged na siya, itong fluorine, 8 dots na siya, negative na yung kanyang charge, then we're done, no? We represented the formation of ionic compounds na. So, ganun lang ka-easy yung representation niya. No? So, instead of writing this 1s2 stuff, no, we can just represent the movement of valence electron using dots. No? This is the question. Sir, paano namin malalaman kung gaano karaming dots ang ilalagay sa isang atom? Easy lang yan. Ganito. So, the number of dots correspond to your group sa periodic table. Tingin tayo dito sa periodic table. We will disregard the D and the F orbital. Itong D block pati F block. No? Hindi natin sila papansinin. Okay? So, tignan natin. For group 1, ano yung ending nila? S1. Diba? Yung lithium, helium, 2s1 yan, diba? Ang sodium, neon, 3s1. So, lahat yan, S1 yung ending, no? So, isang jolly spaghetti yon. So, since lahat sila, S1 yung ending, that means they have 1 valence electrons, no? So, just look at your periodic table. Pag nakita mong nasa group 1 siya, 1 dot yon. Okay? Group 2. Tignan natin. Sa group 2 naman, ano yung ending nila usually? Tignan natin. 2s2. Tingnan ba tayo? 3s2, 4s2, 5s2, Ayun. So, mapapansin nyo, puro S2 yung ending nila. That means they have 2 electrons outside the core electrons. No? So, that means may 2 valence electrons sila. So, 2 dots yun. Na? Skip natin tong transition metal. No? Hindi natin naaralin yan. Kasi pag diniscuss natin yung transition metals and yung inner transition, BS Chem na kayo nun. Na? So, basics na tayo. Okay, so punta tayo sa third period. Third column, third family, the boron family. Ano yung ending ng kanilang electron configuration? Just look at your periodic table. You will see 2s1, 2p1, 3s1, 3p1, 4s2, 4p1. So we are concerned with the s and p orbitals lang, not the d. Hindi natin papansinin yung d and f. Okay, so mapapansin nyo, their ending is always 2s1, S2, S2, P1 na. So yan, S2P1, 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 S2P1 na. So yan, so that means, ilang electrons yon? Tatlo. Dalawa sa S, isa sa P. So that means the boron family would have 3 valence electrons. And we will represent that as 3 dots. No? Tatlong dots. No? Number 4. Group 4, carbon family. So si carbon family, ang ending niyan always ay S2P2. Tignan nyo, S2P2. Neon, 3s2, 3p2. Don't mind the d orbital and the f orbital. Ha? So 4s2, 4p2, 5s2, 5p2, 6s2, 6p2, 7s2, 7p2. So yan. So lahat sila, ang ending nila, no, the outermost electron is the S2P2 or 4 electrons. So that means carbon family would have 4 valence electrons. So that means tuloy-tuloy yan, no? 5 valence electrons for nitrogen, 6 valence electrons for oxygen, 7 valence electrons for fluorine family, and 8 valence electrons for the noble gases except helium. Bakit except helium, sir? Remember, ilang orbitals yung kaya ng first energy level? Isa lang. That is the s orbital. So, ilan yung kayang electron ng s orbital? Dalawa lang, di ba? So, yun. Kaya dalawa lang yun sa kanya. But the rest, yung neon, argon, krypton, xenon, so on and so forth, ano na yan? Tigwawalo na yan, na? So, that's the idea, na? So, instead of writing the whole messy electronic configuration, we can condense all these concepts as dots, no? So, yan. So, dot na lang yung ating basis, no? All you have to do is just to look at your periodic table, no? Tingin na lang tayo sa periodic table and just determine anong group siya. Then, we can represent the dots, no? Okay. So, okay ba tayo doon? Nasundan naman? O, tulog pa tayo. Nasundan naman. Okay na. If you have questions,
Yes
don't
po.
hesitate.
Yes po.
So salamat po. So if you have questions, don't hesitate to ask. No? Sayang yung tuition fee pag di nagtanong. Ay, nag-practice ako dito. Nag-Lewis structures na kami. Ay, ang daming sinulat. Burahin ko lang ha. Hindi ko pala binura. By the way, so ano mapapansin nyo? Na, di ba, for stability, sabi natin, kailangan ng 8 electrons or walang electrons na. Yung 8 electrons, that actually corresponds to the octet rule. Ano sabi ng octet rule? Sabi ng octet rule, for your atoms to be stable, no, especially the non-metals, no, they have to have 8 dots, no, or 8 valence electrons around them, no. So, saan mapupunta yung 8 electrons na yon? Yung 8 electrons na yon, they will be used to fill the S2 and the P6 orbitals. No? So, kaya 8 yan. Kaya octet rule. Pupunuin yung S, pupunuin yung P orbitals. That's why octet rule. 8 yung kailangan. Ay, sorry. Ayan. So, ganun na. So, yun yung idea. Okay. So, with that na, siguro, let's work on namingming. Una. Late daw siya sa klase. Okay. So with that, siguro we can work on writing the Lewis dot symbols for these atoms, no? A to N. Although may naulit dyan, no? Hindi ko na pinansin eh. Okay. So, paano uli natin malalaman kung ano yung dots niya? Just look at the group sa periodic table. First group, 1 dot. Second group, 2 dots. Third group, 3 dots. So on and so forth until the 8th group. No? 8 dots. Okay, so ano sabi dito? Wag na natin i-write yung electronic configuration. Alam nyo na yan eh. So yeah. Draw their Lewis dot symbols. Predict how many electrons must it gain or lose to follow the octet. No? So ayan. So ito yung gagawin natin. Wag na electronic configuration. May na kayo dyan. No? Ako rin eh. So ayan. So gawin na lang natin. Let us represent each atoms with Lewis dot symbols. No? Tapos predict natin ilang electrons kailangan ipamigay or tanggapin for it to be a noble gas configuration or to follow the octet rule. So I will start with letter A, B, C. Then yung D to N, no? Tulungan nyo ako. You can use your microphones, no? Just raise your hand. Teka lang, lobat. Ayun, no? So, ayun, just raise your hand mamaya so I can recognize you. Then, you tell me kung ilang dots and how many electrons ang kailangan ipamigay na. So, para interactive tayo. So, I will start with lithium. Lithium is in group 1. So, that means 1 dot yan. Okay? So, ganun lang. So, that is my Lewis dot symbol. Predict how many electrons, no? So if it will accept 7 electrons, ang effort, no? So ano gagawin niya? Maglo-lose na lang siya ng 1 electron. Okay. So yan. So ganun lang yung gagawin natin. Lithium will lose this 1 electron para maging stable, para maging noble gas. Again, paano mo malalaman kapag noble gas na? Either walang electron sa paligid or kumpleto yung 8 na electron sa paligid. Sige. So, chlorine. Chlorine is in group 7. Galit yung aso sa pusa eh. Ewan ko kung bakit. Okay, so chlorine, group 7 yan. So, 7 dots, no? 1, 2, 3, 4, 5, 6, 7. Anyway, the direction of placing the electrons do not matter for me. Kasi siguro sa iba sa inyo sa high school, kailangan clockwise, kailangan counterclockwise. Ako, bahala kayo. Basta masaya kayo sa buhay, tsaka tama yung sagot na. So, yun. Hindi naman ako maigpit na. Bahala kayo sa life. Matatanda na tayo eh. Okay. So, yun. So, ganun na. Basta don't pair agad, no? Isa-isa muna, no? Okay. So, yan. So, for chlorine, I have 7 dots, no? That corresponds to 7 valence electrons. So, how many electrons must it gain or lose, no? So, you can see, isang step na lang siya, noble gas na lang siya. So, that means it will just gain 1 electron na lang for it to follow the octet rule. Okay? So, I will proceed with phosphorus, then mamaya, tulungan niyo ako. Phosphorus. Group 5 si phosphorus, no? So, that means it contains 5 valence electrons. 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, no? Ayan, so 5 dots na. Okay, so ilang electrons pa kailangan para maging 8? Di 3 lang, no? So yung 3 hindi naman masyado mahirap gawin, no? So it will just gain 3 electrons, no? Sir, kailan namin malalaman kapag pag mag-gain or maglo-lose, no? Pag more than 4, gain na 'yon. Pag less than 4, lose na 'yon. Sir, paano kapag 4? Gain yon usually. Okay, so ganun lang yung idea. Okay. So, bakit sir gain? So, kunwari natanong nyo, bakit ganun sir? Okay, ganito kasi. Remember, carbon is non-metal. So, it won't like to give off the electrons. No? Electronegative atom din yan. So, ayaw niya ipamigay yung electron. So, ayaw niya mamigay ng electron. Yun lang yung point, no? Kaya, instead of giving off the electron, it will just accept, no? And that will be true for these two non-metals, no? I mean the three. Ay, semi-metal pala tong dalawa. Basta for carbon, that is true, no? Tatanggap lang siya ng 4 electrons, no? Itong silicon and germanium, since sila ay metalloids, no? Sila ay semi-metals, they have different properties, no? So, we will not observe them sa ating mga examples, no? Pero yun, ano yung pwede nila gawin? They can follow the carbon's lead, no? Pwede naman nila sundin si carbon, no? Yun. Pero yun nga, balimbing sila. Minsan namimigay sila, minsan hindi. Kaya most of our example will focus on these non-metals, no? Itong mga to. Ayun, no? Okay, so balik tayo. So yun, so since greater than 4 yan, 5 yan, it will just gain 3 electrons, no? For it to follow the octet, no? Okay, so with that, you can help me. D to N, no? Okay. So, letter D. Sino gusto tumulong sa akin? Rina. Ilang dots?
3 po.
3. So, would it gain or lose electrons?
Loose po.
Ilan po?
3 po.
Yon. So, bakit lose? Bakit hindi pwedeng gain?
Since ano po, mas less effort po yung pag-lose compare po sa pag-gain.
Kasi pag nag-gain siya, ilang electrons pa? 5. Ang dami, no? So, it will be better for aluminum to lose electrons. No? So, thank you, Lendra. Rina na lang, no? Sige. So, yan. Alright, so thank you for that. Let's start with strontium, SR. Anyone? Joanna, Joshua?
2 dots po.
2 dots, no? Kasi group 2 siya, no? So, lose or gain, tas ilan?
Lose 2 electrons po.
Okay, lose 2 electrons. So, ganun lang. Kasi dalawa lang yan, no? Pamigay na lang niya. Yan, so thank you. And letter, ano na ako? F, S. Si Kino James. Ilang dots? Kino James.
6 po, sir.
6 kasi group 6 na. 1, 2, 3, 4, 5, 6. Would it gain or would it lose?
It will gain 2 electrons po.
Okay, so gain 2 electrons na lang kasi effort kapag ipamamigay niya lahat na. Okay, so yan. So thank you. Silicon. Angela Bianca. Magtoto.
4 dots po.
4 dots na.
And
So ano yung gain or lose?
gain po. Gain 4 electrons.
So again, pag group 4, pwedeng dalawa yung case, no? It could gain or it could lose, no? Depending on the case, no? So acceptable naman sa akin yun, don't worry. Pero si carbon, pag carbon yung tinanong, gain agad yan, ha? Kasi electronegative yan, eh. I mean, non-metal kasi yan. Si silicon kasi, semi-metal yan, so medyo balimbing yan, so hindi mo alam kung magigain yan or maglo-lose yan, no? So yan. Basta kapag carbon, gain agad, pero yung silicon, germanium, balimbing, no? So we cannot say kung ano talaga gusto nila gawin sa life, no? Okay, so thank you. Oxygen. Si Elijah May.
6 po na dots.
6 dots. 1, 2, 3, 4, 5, 6. Tapos ilang electrons ang i-gain or i-lose?
Gain po ng 2.
Gain ng 2 electrons na. Okay, so yan. So thank you. Magnesium. Si ano naman? Alexander Zar. Nag-raise ba siya ng hand? Hindi ko napansin, eh.
Ano po ulit sa magnesium? 2 pong dots.
2 dots, no? Tapos, gain or lose?
Lose po. 2.
Lose 2 electrons. Okay, so thank you. And fluorine. Ayesa. Isabel. Ayesa.
Fluorine po, 7 dots.
7 dots. 1, 2, 3, 4, 5. Yan. So, yan, 7. Then, lose or gain?
Gain 1 electron.
1 electron. Okay, so thank you. Aluminum. Angelica Marie Sejas.
5 po, sir. Tapos
5.
gains 3 electrons.
Aluminum,
Ay. Wait. 5 po.
5.
Tapos gains 3 electrons.
Ang aluminum ay, eto nasa third group.
Okay, wait lang.
Nasa
Hala,
third column siya.
wait, sir.
Sige po.
Hala, wait lang. Hala, sige, sir. Sa iba na lang kasi di ko maano. Sorry po.
Okay lang. Okay lang. So, si aluminum nasa group 3. So, 3 dots na. So, and would it lose or would it gain? It will lose, no? So, yan. Lose 3 electrons, no? So, yan. Yung sulfur na sagutan na natin potassium. Angelica Marie, uli. Sige. Sejas. Potassium.
Ano po, sir? 1 po.
1 dot and lose or gain?
Maglulus po siya ng electron.
Okay, 1 electron only. And last one, bromine. Let's have Trev Mark Line.
Meron pong 7.
7 dots.
So, mag-gain ng 1 electron.
Gain 1 electron. Okay, so ayan. So thank you very much for your participation. No? Okay, so ayan. So we're pretty much done with ionic compounds. Ngayon, ganito naman yung task natin. Mahilig tayo mag-ship ng tao, di ba? So isi-ship din natin yung mga atoms to form compounds, ionic compounds na. So we can actually predict the formula of ionic compounds by just determining how many valence electrons would it give or would it accept na. So maglalagay ako dito ng, let's say, 6 na pairs. Gagawin ko yung 2, tapos kayo bahala sa iba na. So, sulat ko muna. 1, 2. Mag-ship tayo ng atoms ngayon. Okay, so yan. So let's do this. No? Ano task natin ngayon naman? This time, we are going to pair the electrons. No? Hanggang anong oras ba tayo? 12:30 naman. 11:50 na pala. Ang bilis ng oras na. So, ano gagawin natin? We are going to pair the electrons. Pares-pares tayo ng atoms. No? Then we will predict the formula. No? We can do that by just showing. No? By just showing the movement of electrons. No? Yung valence electrons. For example, lithium and Cl. 1 dot lithium, 7 dots Cl. No? Okay. So, ano yung pwede natin gawin? No? Lithium can give off its 1 valence electron to Cl. No? So, pag nawala yan, tapos na. Positive charge is lithium, negative charge is Cl. So, ilang atoms yung kailangan para magawa yung compound na yan? Tig-isa, no? So, isang lithium, isang chlorine. So, the formula is lithium chloride. Ganun lang. No? So, yan. So, nasagutan ko na yung 1. Sagutan ko yung 4. Okay. So, sasagutan ko naman yung 4. Papakita lang natin yung movement ng electron. So for aluminum and fluorine, mapapansin nyo, fluorine can only accept 1 electron from aluminum. So meaning isa lang yung pwede ibigay ni aluminum doon. So ano mangyayari? Sobra pa si aluminum ng 2. So anong gagawin? Kailangan niya pa ng iba pang fluorine atom. So hanap pa tayo ng isa pang fluorine atom. Okay, so ito yung isa pang fluorine atom. Anong gagawin? Itong electron na yan, bibigay natin doon. So, yan. Octet na yung dalawang fluorine. May sobra pa si aluminum. So, ano pa gagawin natin? Isa pang fluorine atom. Okay. Then, yun. So, tatanggapin niya yung last remaining electron ni aluminum. So, kumpleto na yung octets ng 3 fluorine. Wala ng electron si aluminum. So, we're done pag ganun na. So, since aluminum lost 3 electrons, the charge will be positive 3. Since all these fluorine accepted 1 electron each, they will be negatively charged, no? Negative 1. Paano yung formula niyan? Siyempre, unahin mo yung metal, aluminum. Tapos, ilang fluorine atoms ginamit natin? 3. So, we will represent that as a subscript. AlF3 ang formula for a compound with aluminum and fluorine ions. No? Ayan, so ganun lang yung ganun lang yung gagawin nyo para sa mga compounds na to. No? So saan nyo to gagawin? No? I want you to answer these 3, these 4. Dagdagan ko na ng isa pa para mas masaya. Papa-upload ko na lang sa inyo sa Canvas. No? Ilagay ko dito 7. 7. Ano kayo pwede? Okay, so I want you to pair, to draw the movement of electrons from one atom to the other atom. Then you predict the formula. Okay, so ganun. So yan, so gawin nyo yung number 2, 3, 5, 6, and 7. So ganun lang. Pakita nyo lang yung Lewis dot. Ibigay mo yung electrons na dapat bigyan. Pag octet na, tas may sumobra pa, edi drawing ka kaulay ng isa pang atom. Do that until all atoms contain 8 electrons or the metal no longer contains any electrons outside. Then yun, you count the number of atoms and the metals. You count the number of atoms and you make it your subscript. So, ayan, you get the formula. So ganun lang muna. So siguro screenshot nyo na lang yan. Screenshot ko na lang din para makita nyo. By the way, ito na yung magiging GC natin for the rest of the time. Kasi naumay din ako kakagawa ng bagong GC. Kasi para dito na lahat ng pinagagawa natin. So until December na to. Comment ko mamaya itong picture natin na to. So, para masagutan nyo. So, sulat nyo lang yan sa paper or kung may iPad kayo, may tablet, sulat nyo doon, then post nyo sa discussions page sa Canvas. Just like yung pinagawa ko sa aking ibang students, although laboratory naman to. So, yan, ganito lang. Para naman mabuhay yung discussions natin. So, ayan. So, nagko-comment sila ng Lewis structures. Ayan, diba? #interactive. So anyway, so ganun lang ha. Sagutan nyo na lang yan. Message ko mamaya yung itong part na to. Okay? So, lagay nyo sa discussion sa Canvas. Okay, so let's go back. So we're done with ionic compounds. So ionic compounds, metals lose electrons, non-metals gain electrons. So they will be stable now. Okay. How about if parehas may non-metal dyan? Would it be possible? Yes. Bakit? Yung water molecule natin, walang metal dyan, pero it exists. Yung air na hinihinga natin, yung oxygen, nitrogen, they exist kahit walang metal doon. So that means, hindi lang naman pala kailangan na may metal and non-metal for a compound to exist. And ang tawag natin sa compounds with no metals ay covalent compounds. So, walang metals doon. So, that means also, walang mamimigay ng electron. So, siguro, ang tanong nyo, paano sila magiging octet? Paano sila magiging stable? Ganito. Yung ating covalent compounds, since they do not like giving off electrons, they will instead share them. Share na lang sila ng electrons, no? Parang kayo ng mga friends nyo, no? Kanya-kanyang burautan, no? Share ng pagkain. So, ganun. Ganun din yung covalent compounds. No? So, walang willing mamigay ng pera, no? Walang manlilibre ng samyup. Instead, ambag-ambag, no? So, ganun yung idea ng covalent compounds. No? So, again, what do we have here for covalent compounds? When we say covalent compounds, these are compounds without any metals. No? Walang metals dyan. So, how is the compound possible? Paano na-form yan? Diba, they have to give or take electrons to be octet. No? That's not the case. No? For covalent compounds, they do not really want to give off or take in electrons. No? Ano ginagawa nila? Share na lang. No? So, pinaghahatian nila kung ano yung meron sila to form a compound. No? And this will be discussed in depth in your laboratory, yung pagdraw ng structures, no? The Lewis structures. Pero anyway, so punta muna tayo sa concept na. Let's have some examples of covalent compounds such as hydrogen gas, H2. One dot. No? Okay, so yan. So we have two hydrogen atoms. Yan yung sinasabi ng formula. How are they going to be stable? Sabi natin, for the first period, first energy level, dalawang electrons lang yung kaya because the first energy level only contains one s orbital. Walang p orbital doon. So, instead of octet, 2 electron rule lang tayo. So, ganito. Isipin nyo, etong dalawa, non-metal yung hydrogens natin, di ba? Okay. Pag hinila na itong hydrogen na to yung electron nun, kunwari ginanon natin, ano mangyayari dito? Mawawalan siya ng electron configuration. So, ano siya? Wala na siyang dangal. Yun yung idea. So, mawawalan siya ng identity. So, hindi pwede yun. No, huwag ganun. So, instead na mawalan ng dangal yung kaibigan niya, mag-share na lang sila ng electron na. So, para may ano pa rin sila, may electronic configuration na. So, never mawawalan ng electronic configuration, ha? So, kailangan meron pa rin, no? So, ano gagawin nila, no? So, mag-fusion sila, no? They will combine those electrons to form a bridge. We call this bridge the covalent bond, no? So, yan. Pagdudugtongin nila yung dalawang electrons nila para ma-form yung compound, no? Okay, so they will form a single bond, no? Ano meron sa single bond? 2 electrons joined together, no? So, yan. Yan yung covalent bond natin. So, as they do so, what will happen is the 2 electrons will now be equally shared sa kanilang dalawa. Okay, so, ito yung green. Yan yung dalawang electron. Tapos yung bridge, yung bond, dyan dumadaloy-daloy yung electron. No? So, satisfied na sila dyan. How come? Ganito. If you want to check if the atom contains the necessary amount of electrons for it to be stable, gagawa tayo ng borders. No? So, paano gumagawa ng borders? No? Mamili ka ng atom. Kunwari, ito gusto ko tong atom. I will draw a curve in which I will encompass my end of the line. No? So, sakupin ko yung dulo ng line. So, gagawa ako ng curve na sakop yung dulo. Okay? So, for this atom, that means, mukha siyang mukha, no? Lagyan natin ng happy face. Ayan. So, for this atom, how many electrons yung nakapalibot sa kanya? Bilangin natin yung dots. 1, 2. Okay, so may dalawa ng electrons na nakapalibot kay hydrogen. The question is, yun ba yung requirement ni hydrogen? Yes po. Kasi again, the 1s orbital can only accept 2 electrons. And by accepting 2 electrons, helium na yung kanyang configuration. So that means, okay na yan, no? So we're pretty much done with that hydrogen. Tignan natin yung kabila. Kung ganun yung case sa kanya, malay mo, hindi pala, no? So gagawa ulit tayo ng curve. Sakop yung dulo. Then bilangin mo yung dots. For hydrogen, it only requires 2 electrons kasi 1s lang meron siya. So ilan yan? Dalawa. So satisfied na yung kanyang pangangailangan. So that means hydrogen gas can exist, no? By forming covalent bonds, no? No atom will give off the electron. Instead, they will share the electrons, no? So let's work out with some more examples, although yung in-depth discussion dito would be given by your laboratory when you start drawing the Lewis structures. I don't know if you started na, no? Pero yun. Let's try oxygen. Okay, so this is my oxygen atoms, O2. Paano naging possible yan? Kung kukunin ni oxygen na to, yung dalawang electrons doon, magiging positive 2 yung charge niyan. X yun. Hindi ma-form yung compound na yan. So, ano pwede nila gawin? They can form bridges, no? Yan. Pwede nila ipagdugtong yung dalawang electron na single nila. Yan. And they will form double bonds, no? So, as they connect those two electrons, they are forming double bonds. And at each end of the double bond, andun yung dalawang electron na pinagdugtong nila. To check if it follows the octet rule, kasi kailangan na 8 for oxygen, gawa ka ng border again. Bilangin mo yung dots na nakapalibot dito. 1, 2, 3, 4, 5, 6, 7, 8. So yan, so octet na yan. So tingnan natin din sa kabila. Bilangin natin yung dots. 1, 2, 3, 4, 5, 6, 7, 8. No? So by just sharing the electron, they satisfied the octet rule. So okay na sila. No? So yan. Ayun, no? So ganun lang. No? So that's the idea about this, the covalent bonds. No? Last example maybe, N3, N2, nitrogen gas. Nasa hangin to, no? Ito din yung nasa pagkain natin, no? Yung mga chips. Dito ko na nilalagay yung dalawang dot. 2 dots. Okay. So, yan na. So, ano gagawin nila? Walang mga agaw ng electron dyan. Instead, they will just share the electrons. No? So, they will connect these electrons to form chemical bonds. That will be a triple bond kasi tatlong lines yung nagawa nila. No? So, at each end of the bond, you have 2 electrons. To verify if it follows the octet rule, you can draw a border and count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. Octet rule. Okay? So, okay na yung nitrogen dyan. Tingin tayo sa kabila. Ilang electron? 1, 2, 3, 4, 5, 6, 7, 8. So, octet rule din. So, yan. So, we can see, no, na it doesn't really necessarily mean para maging stable is kailangan may mamigay ng electron. Pwede rin pala mag-share na lang, no? So as they share their electrons, they form covalent bonds, no? So gumagawa sila ng covalent bonds, no? Yan. So we can have we can have single bonds, we have double bonds or triple bonds, no? So paano ma-form yan? So depende kung ilan yung electrons na kailangan nila i-share para maging noble gas configuration. Si lecture na yung bahala mag-discuss kung paano magdodraw ng iba pang Lewis. I mean, si lab pala. No? Si lab na yung bahala kung paano magdodraw ng ibang Lewis structures. Na. So, yun yung idea. Okay? So, yan. So, yan. So, by just sharing the electrons, we satisfy the octet rule for some atoms. Na. Hydrogen, hindi siya magsasatisfy ng octet rule kasi dalawa lang yung kailangan. No? And we can form multiple bonds. No? Let's draw some examples pa. Let's say HF, hydrogen fluoride, HCl then, 1 dot, 7 dots. Ay, F yan. Cl pala. Okay, so let's have these two compounds. Hydrogen fluorine HCl Ito yung muriatic acid sa CR. We can connect these bonds, no? Yung mga tig sa single bonds, no? And let's verify if satisfied na yung requirement nila. For the hydrogens, look, no? Ilang electrons yung nasakop nila? Tig dalawa. So, satisfied na siya kasi dalawa lang naman yung kailangan niya. For fluorine and chlorine, tignan nyo. Ilang electrons sakop niya? 2, 4, 6, 8. 2, 4, 6, 8. So, satisfied na rin yung octet rule. So, that means this compound can now exist na. But ito, let's recall the concept of electronegativity, no? So, hopefully napanood nyo yung yung recording namin sa isa kong class, no? Alam ko naman napanood nyo kasi dumami yung views niya, no? Okay, so, ano yung concept ng electronegativity, no? Balik tayo sa periodic table. The further you go to the right side of your periodic table, the electronegativity increases. Ano yung sagot doon? Bakit? Because, di ba remember, they want to be noble gases, di ba? The nearer they are to the noble gas, that means ganun yung desire nila for the electrons. No? Gustong-gusto nila ng electrons or ganun sila ka-electronegative. No? So that's why the trend for electronegativity is going to the right side. It increases. No? Bakit? Kasi andun yung noble gas. No? Itong mga atoms na to, gustong-gusto na nila gayahin yung noble gas. No? That's why mataas yung kanilang electronegativity. While the atoms on the left side, mababa na yung electronegativity nila. Bakit? Kasi ang layo nila sa noble gas. No? So they really don't like electrons that much. Papamigay na lang nila. While this one, they really love electrons. So kukunin nila. No? So yan. Bakit yung xenon, sir, may electronegativity? Ganito yung reason dyan. Kasi yung xenon, masyado siya maraming electrons. So, remember, atomic radius, the bigger your number of electrons, the farther your electrons are. No? Masyado na kasi malayo yung electrons ni xenon, kaya hindi na niya mahawakan masyado. So, yun. So, it can participate in chemical reactions. No? So, anyway, exemption lang naman yan. Balik ulit tayo dito. So, if we have two different atoms in our compounds, that means may magkakaibang electronegativity yan. Si fluorine, iba yung electronegativity niya with the hydrogen. Si chlorine, iba yung electronegativity niya with the hydrogen here. Paano natin malalaman kung saan yung electron madalas? No? Okay, ganito. So, remember, our electronegative atom really loves electron. So, what they will do is that, di ba, nag-form na sila ng bond. Hihilahin nila yung electron towards itself. So, that means the most electronegative atom will pull the electrons. Paano natin, sir, malalaman yung electronegativity? Kung sino yung malakas, sino yung hindi? As long as you remember your periodic trends, no, kaya natin sagutan yan. O kaya, you can use this table na meron ako sa handouts ko. Andito yung electronegativity map, no? So, yan. As you can see, it increases, no? Going to the top right, no? We can actually use the values, no? Itong electronegativity values. So, gamitin natin para mas ma-quantify natin yung difference, no? So, for fluorine, the electronegativity is 4.0. Nasa table yan. No, don't worry. Wag nyo kabisaduhin din, no? Nasasanay na lang kayo. Ang kailangan nyo kabisaduhin ay periodic trends, no? So, yan. So, ito yung mga electronegativity ng mga atoms sa bonds na to, sa covalent bond natin. So, 4.0 for fluorine, 3.0 for chlorine, and 2.1 for the hydrogens. Since we know that fluorine is more electronegative than hydrogen, what would be its tendency? It will pull the electrons towards it. Paano natin ipapakita yon? We can draw an arrow pointing to fluorine. So, it will pull the electrons of hydrogen towards the fluorine. So, ganito din kay chlorine, no? Sir, may bond pa rin ba? May bond pa rin, yes. Pero hihilahin niya lang yung electrons towards sa kanya. Clingy siya eh, no? So, yun yung idea. The electrons will be pulled towards fluorine, towards chlorine, because these atoms are more electronegative than hydrogens, di ba? Okay, so ganun yung idea. Ano mangyayari? Ano yung consequence May consequence yan. With the different electronegativities, we can have different types of bonds now. We can have non-polar covalent, we can have polar covalent, and ionic bond. So ito yung complication niya. If you have bonds with two different atoms, the difference in their electronegativity can cause different types of bonds. Pwedeng non-polar covalent, pwedeng polar covalent, and pwedeng ionic. Okay? So, alamin natin to, no? So, tignan natin. Ano mangyayari if non-polar covalent yung iyong bond, no? That means, wala lang masyadong mangyayari. No? Nothing much will happen. Non-polar yung magiging molecule mo. When we say non-polar, ano ba meaning ng polar? May positive and negative ends na. So for non-polar molecules, walang ganon. Wala siyang positive and negative ends na. For polar covalent molecules, dito nagkakaroon ng positive and negative ends na. And for ionic bonds, we know na may full charge tayo. No? Stronger yung positive and negative charges na. So let's look at this electrostatic map of hydrogen fluoride. Ayan, so that's hydrogen fluoride. Remember, fluorine is 4.0, hydrogen is 2.1 in electronegativities. Ano mangyayari? Fluorine will pull the electrons of hydrogen. That's why we will see redder part dito sa fluorine. Pulay siya. The red means maraming electron. The blue part means onti yung electrons. So we
Love!
ayun. Okay. So sige. So tignan natin na. So etong right side, kulay pula siya. So meaning nun, maraming electrons doon. So ano mangyayari? So the right side will bear the negative charge, no? The left side will bear the positive charge. Bakit sir nagiging negative pag red na? Kasi remember, if maraming electron, ano yung charge ng electrons? Negative. Pag walang electron, edi positive, no? So ganun. So that means this will be polar, no? But again, since covalent bond yan, hindi yan ionic, we will not have full charges. Hindi siya full positive and full negative, no? So instead, we will signify this as partial charges, no? Itong parang 8 na yan, meaning yan ay partial. So ano yung idea ng partial, no? So hindi siya fully charged. So that means hindi siya ions, no? Pero there is a pool of electron, no? May imbalance ng electrons, no? So meaning ng partial again, hindi full yung charge, no? Kailan nagkaka-full ng charge? Pag ionic. Pag polar covalent, partial yung charge, no? So yan, on the right side, partial negative, meaning nun medyo negative. Bakit medyo negative? Kasi andun yung electrons, no? Dito medyo positive kasi walang electrons, no? But still, they are connected by a bond, no? So yan. So ganun lang, no? That's how we predict where the electrons are. Just identify yung partial charges. I mean, identify which of the atoms would be the most electronegative atom, no? So pag na-identify mo na kung sino yung mas electronegative atom, sa kanya yung negative charge or the partial negative charge, sa kabila yung partial positive charge. No? So yan. So with that, no, we can start classifying the bonds whether they are ionic, polar covalent, or non-polar covalent. No? So tatlo muna tayo. Actually, you can answer all of this now. Pero sige, ano na lang tayo dito. Dito lang muna tayo. Just to end this topic na. Okay, so yan. So bond in HCl. So draw mo muna yung structure niya. Again, then look at the electronegativity table. Hydrogen is 2.1, chlorine is 3.0. Then ano gagawin natin? We will get the electronegativity difference. Paano yan sinasolve, sir? You just subtract the big number with a small number. So En or delta En, electronegativity difference, that's 3.0 minus 2.1. So ano yung sagot? 0.9. So pag 0 point yan, tingin kayo dito sa sa line ito, ang tawag doon. Basta yan, tingin kayo dyan. Hanapin nyo dyan kung nasaan yung 0.9. So, yan. So, for nonpolar, it starts with 0 to 0.4. The polar covalent bond starts with 0.4 to 1.8, and anything beyond 1.8 is considered ionic na. So, since ang electronegativity difference ng ating dalawang atom ay 0.9, hanapin natin yung dito sa line. So, on 0.9 ay andito somewhere, no? Andiyan yung 0.9. So, saan siya nagpo-fall? It falls on the polar covalent bond, no? So, that means our molecule is polar covalent, no? So, that means polar yung HCl. Okay? So, yun lang yung idea. Polar siya. KF. Ito, technique. Pag may metal at non-metal, ionic agad yan. Pero let's see. Let's confirm. Potassium is 0.8. Sabi dito. Fluorine is 4.0. Sabi dun sa taas. So, let's obtain the delta En or the change in electronegativity. That's 4 minus 0.8. 3.02. 3.02. Ay, hindi. 3.2. Okay. So, 3.2 yung electronegativity difference. So, tingin tayo dito sa line natin. Asan yung 3.2? Somewhere beyond 1.8. No? So, andun yung 3.2. So, that means the KF bond is ionic in nature. Ionic bond yan. No? So, ions yan. No? Okay. Last one, CC bond. No? The CC bond. Okay. So, ano yung electronegativity to carbon? Carbon is 2.1 in electronegativity. Ayan. So, carbon is 2.1 in electronegativity. Carbon is as well 2.1 in electronegativity. So, ano kaya yung change niyan? 2.1 minus 2.1, 0. So, hanapin mo dito sa graph natin, asan yung 0? Ito. So, saan nagpo-fall siya? Sa non-polar covalent bond. No? So, that means the bond between carbon and carbon is non-polar covalent. No? Ito yung question. Sa mga tatlong uri ng bonds na to, asan yung charges? So, I will start with the non-polar covalent. No? Since ang term natin ay non-polar, ibig sabihin nun, walang charges. So, wala akong ilalagay na positive or negative o kaya partial positive or partial negative. No? Wala akong ilalagay na ganun. For ionic bond, ibig sabihin nun, may charges. Ionic eh. So, kanino mo ilalagay yung positive? Edo yung sa metal. Yung negative yung sa non-metal. For polar covalent, saan mo ilalagay yung partial negative? The partial negative will be placed kay chlorine. And yung partial positive would be kay hydrogen. Okay, so ganun yung idea. Bakit ilalagay yung partial negative sa chlorine? Because they love electrons. They will pull the electrons towards itself. No? So kaya partial negative dyan. Dito partial positive kasi ito yung nawawala ng electron. No? So ganun lang yung idea. Pag polar covalent, partial charges. Partial negative sa electronegative atom. Partial positive sa less electronegative atom. Pag ionic bond, positive and negative charges. Saan yung positive? Kay metal, negative kay non-metal. For non-polar covalent, wala kang ilalagay. No? Okay, so with that, we're done with our target no, for this day. Sayang, onti kasi yung 3 hours. Onti lang yung 2 hours to discuss everything. No? Pero, ayun. Since this chapter is 2 weeks naman ang kanyang allotment, then we have some time, no? Medyo marami tayong time for this chapter. And ang gagawin ko, by weekends, no, magre-record na ako ng lessons talaga, no? As in, separate siya from our class recordings. Kasi, if you watch the class recordings, it takes 2 hours masyado or 1 hour higit na. Sir, about saan po yung quiz 1 and quiz 2? So, yung quiz 1 nyo, that is about the nature of chemistry lang. No? Chemistry, matter, how to classify matter, yung mga ganong idea na discuss natin. Quiz 1 and 2, ganun na. So, about siya sa matter. So, yan. So, kahit wala kayong access code, you can do this now. This is open until Saturday naman na. So, yan. Yan. Matter, energy, atoms, and matter and energy, atoms, as energy na naman. No? So, yan. So, tignan nyo na lang. Oh, yan. So, yeah. Oops. Ganun na. So, yan. So, madali lang yan. No? May mga naka-perfect naman ata. No? Oops. Okay. So, hindi ko na tinignan. Yung lecture, yung quiz 2 naman, that's about the periodic table. No? More on periodic trends lang. Although madali lang siya. No? Mas madali. Alam po may naka-perfect dito eh. So, ano itsura? Yun. Yan. Mga ganyan-ganyan lang. Case-to-case basis. No? So, yan. Pero siguro I may extend the deadline. No? Ay, sige po. No, any questions? Wala naman pong computation. Ang computation ay kay lab eh. Kaya, mabilis lang yung lecture. As in, more on concept lang. So, alam ko kaya nyo na yan. No?
Sir, question po about pairing the electron.
Ay, sige po.
Sir, yung sa subscript po ba, malalaman po yun sa number of dots na nilipat?
Not necessarily. Hindi naman necessary. No? Tingin tayo ng example. Yung subscript that corresponds to the number of electrons na nilipat. Ng metal, pwede. Pwede yun sa metal. Pero, pag tinignan nyo yung MGN, medyo iba yung case dyan eh. So, kaya sinabi kong not necessarily. Kasi dito, yes, yung subscript ng F, corresponding siya sa electrons na binigay ni AL. No? Sa MGN, check nyo pa na. Pero yan. So, yan. May may mga techniques pa tayo sa pagdetermine ng ionic formula. So, madidiscuss natin yung next meeting. No? So, yan. Siguro lang, just count muna. No? Then, later on, makikita niyo kung bakit ganun talaga yung subscript niya. No? So, yan.
Okay po, sir. Thank you po.
Okay. So, ngayon lang tayo nakapag full class discussion. No? As in, yung 2 hours talaga. No? So, yan. So, end ko na yung recording. I will upload this later tonight. No? So, yan. So, if you have any questions, don't hesitate to ask